Okay, this video is going to be over absolute value equations and inequalities. But before we do that, I kind of want to do a couple more examples of stuff we did in the last video, the one about the compound inequalities. So here's an example. Solve 3x plus 1 is greater than negative 5 and 2x plus 5 is greater than 7. That means the same value of x has to fit both inequalities. Alright, so for the first one, if you subtract 1, you have 3x is greater than 6, which tells you that if you divide by 3, x should be greater than 2. So first of all, we need a number that's greater than 2. Now we need to solve the other inequality. Well, I forgot the negative sign, so that'd be 3x is greater than negative 6. So x is greater than negative 2. Now if we solve the other part of that inequality, 2x plus 5 is greater than 7. If we subtract 5, that means 2x is greater than 2. And if we divide by 2, x must also be, the number we're looking for must also be greater than 1. So we need all the numbers that are both greater than negative 2 and greater than negative 1. So if you want to look at that on a number line, the numbers that are greater than both negative 2 and that should be positive 1, the numbers that are both greater than negative 2 and greater than negative 1 are those here that are just greater than negative 1. That'd be a parenthesis since we're looking for numbers that are strictly greater than 1. That's what it means by and. It has to fit both inequalities. If you want to know the shorthand for writing both of these inequalities, x is greater than negative 2 and x is greater than 1, that'd be negative 2 is less than x and x is greater than 1. You can always just write it as a compound inequality like this. Just make sure the symbols are pointed in the correct direction. Alright, so here's another example. Solve this compound inequality. 2x minus 5 is less than negative 11, or 5x plus 1 is equal to 6. That means it has to fit one inequality or the other, but whatever number we choose does not have to fit both. So if we solve the first inequality, add 5 to both sides, so we'd have 2x is less than negative 6 divided by 2, and x is less than negative 3. And if we solve the other inequality, 5x plus 1 is greater than or equal to 6. Subtract 1, I don't know why I wrote subtract 6. Subtract 1, and 5x is greater than or equal to 5. Divide by 5 on both sides, and x is greater than or equal to 1. So now, if you want to graph this, I believe our two numbers were negative 3 and positive 1. Now for the negative 3, it was strictly less than, so it would be a parenthesis. That's how your book tells you to draw it. Although, I know in previous math classes or in previous grade levels, you may have been taught to draw an open circle whenever it's strictly less than. But anyway, I'd like for you to do the parentheses. And since for the 1 it's greater than or equal to, it would be a bracket. And you'd shade the other way. So as long as the number you choose falls in one of those intervals, it works. Alright, so for this example, I want you to determine the following. I have 3 different problems for you, A, B, and C. Alright, so for part A, you notice that's between 0 and 8. And you notice it contains numbers greater than 0, and since it's a parentheses, it's strictly greater than. And since it looks like it's a parentheses around 8 as well, but it contains numbers less than 8. So it has to fit both inequalities, since since it just contains the numbers in between those two. So pick any number in that interval and it would fit both inequalities. So that's how you know it's an and. X is greater than 0 and x is less than 8. So if you want to write this as a compound inequality, it'd be 0 is less than x is less than 8. Or if you want to write it in interval notation, it'd be from 0 to 8 with parentheses because it does not contain the endpoints. For part B, since it goes off in either direction, that means it'd be an or inequality. The number just has to fall in one of those intervals or the other, but it obviously can't be in both. So for -3, you notice since it goes off to the left, it wants numbers less than -3. It'd be strictly less than because it's a parenthesis. Likewise, for +3, it'd strictly be greater than instead of greater than or equal to because it doesn't contain the parentheses. And we said it'd be an or. So that's how you can write it as separate inequalities. Or if you want to write it as a compound inequality, it'd be -3 is greater than x, and x is greater than +3. Or if you want to write it in interval notation, it'd be from -infinity to -3, and it'd be parentheses around both, and it would be unioned with the interval from 3 to infinity. And that would be parentheses around the infinity as well. Now on to absolute value. In simplest terms, the absolute value takes any number and makes it positive. All it does is measure the distance from 0 on a number line. And here's a picture on the following slide of what I'm talking about. And so as you can see from the diagram, if you go 3 units over in either direction to 3 or to -3, it says that the distance is just +3. That's what it means by absolute value. The absolute value of the distance is equal to 3, regardless of which direction you're going in. Now we're going to do some examples of some equations and inequalities you might be required to solve. Alright, so here's an example. Solve this absolute value inequality. 5 minus 3x is equal to 12. Or the absolute value of this is equal to 12. Well, since it's absolute value, the stuff on the inside might be equal to +12. Or it might be equal to -12 since the absolute value only measures distance. So we have to solve each one separately. So now let's solve each equation. Subtract 5 from both sides, so -3x is equal to -7. So x, if you divide by -3, you have x is equal to -7 over -3, which would be -7/3. That should be a +7. That's why it's -7/3, because that should be a +7 up there, because 12 minus 5 gives you +7. Positive divided by negative gives you a negative. So if we subtract 5 from both sides, those cancel out, so you have -3x is equal to -17. Divide by -3. And x is equal to +17/3. Alright, so we can write our solution set with brackets. With squiggly brackets, it'd be -7/3 and +17/3. Alright, here's another example. Solve the absolute value of 4x minus 3 is equal to the absolute value of x plus 6. Alright, when you have two absolute values that are equal, they're either equal in value or opposite in value. What this means is that 4x minus 3 is equal directly to x plus 6, or 4x minus 3 is equal to negative, to the opposite of x plus 6. So we have to solve each of these equations separately. Okay, so for the first equation, 4x minus 3 is equal to x plus 6. If you subtract x from both sides, and also add 3 to both sides. Negative 3 and positive 3 cancel out, x and minus x cancel out. So you're left with 4x minus x, which is 3x. 6 plus 3, which is 9. Divide by 3. So you have that x is equal to 3. Now if you solve the other equation and distribute the minus, you would have minus x minus 6 is equal to 4x minus 3. Now if you combine like terms, add x to both sides, and also add 3, on the right hand side you can't see that, but that's negative 6 plus 3, which would be minus 3. The minus x and the plus x cancel out, the minus 3 and the plus 3 cancel out, and the 4x and the x add to 5x. So it should be, if you divide by 5, that x is equal to negative 3/5. So we can write our solution set using the brackets, using the squiggly brackets, and we always put the lower number on the left, negative 3/5, and then positive 3. And here's a nice chart of what you can expect your answers to look like. It says whenever you have the absolute value is equal to a number, you're just going to have 2 dots on a number line. And for case 1, whenever it's just an absolute value equation, it's equal to k or negative k, you can write your solution set using squiggly brackets. Let me rewrite that 1. And for case 2, when absolute value of x is less than a number k, you saw how both inequality symbols were facing towards the right, they were open towards the right, and it contains the graph in between there. So when you have the absolute value of something is less than x, you can expect the solution set to be just an interval. It'd be the interval from negative k to positive k. And for case 3, when you have absolute value of x is greater than k, you saw how the intervals were going off in opposite directions, so that'd be from negative infinity to negative k, unioned with the interval from k to infinity. Alright, so here's an example of when you would use it. Alright, solve this absolute value equation. Absolute value of 3x minus 1 plus 4 is greater than 6. Alright, so if you subtract 4 from both sides, we can get the absolute value by itself. Absolute value of 3x minus 1 is greater than 2. So we can do the same thing we do with the absolute value equations. We can split them up into separate inequalities. 3x minus 1 is greater than 2. And we notice that'd be an or symbol. So or negative 3x minus 1 is greater than 2. So we have to solve both of them and then graph it. You know it's going to go off in opposite directions. So let's solve the first one. 3x minus 1 is greater than 2. If you add 1 to both sides, you have that 3x is greater than 3. Divide by 3. And you have x is greater than 1. So now let's solve the other one. Negative 3x minus 1 is greater than 2. Distribute the minus, so minus 3x plus 1 is greater than 2. So if you subtract 1 from both sides, you have negative 3x is greater than 1. So if you divide by negative 3, that should tell you that x is less than. Remember, since we divide by a negative, you have to flip the inequality symbol, so it would be less than now negative 1/3. So if we graph it on a number line, negative 1/3 and 1, since they were both strictly less than or greater than, no equal to on either of them, that means they'd both be parentheses. And they would both go off in opposite directions because we want x is less than 1/3 and x is greater than 1. So here's an example. I want you to solve and graph this absolute value inequality. The absolute value of 2x plus 1 is less than 7. Remember, we have to split it up into separate inequalities and solve each one separately. And you know, since it's less than, you can write it as a compound inequality. You can write it as just negative. If you look at your chart, since it's strictly less than, you can take the stuff on the inside, 2x plus 1, and write it like this with both inequality symbols facing towards the right. And just solve it like this. Subtract 1 from both sides. Or subtract 1 from everything. So you have negative 7 minus 1, which is negative 8, is less than 2x, and 2x is less than 6. So divide by 2. You find that negative 4 is less than x, and x is less than 3. Alright, before we get to graphing that, I just want to show you the other way you could have done it if you don't like it that way. You could have done 2x plus 1 is less than 7, and negative, then open parentheses, 2x plus 1 is less than 7, and solved both of those separately. But I think once you get used to this, it might be a little bit easier, a little bit less work for you. But anyway, if you draw it on a number line, it's from negative 4 to 3. It'd be parentheses on both of them. And since it wants the numbers greater than 4, but also less than 3, you'd shade in between there. Alright, I want you to solve this. Okay, if you notice, we have absolute value, so whatever number you plug in there is always non-negative. So if it's always non-negative, it will always be greater than this negative 4. So it would be all numbers from negative infinity to positive infinity, or just the set of all real numbers. So both of these answers would work.